Hi, everybody. My name's Yvea Moore. I'll spotlight myself really fast. And this is my awesome buddy and fellow mathicist, Susan Beckhardt. And yes, we just said mathicist. Um, and we are here today to talk about.
Lots.
We're going to do some plotting. Um, so to start with, why plots? Why do we want to do this?
Good question. Yeah. So plots as opposed to just numbers. We talk about putting numbers in our nature journal, and then no, those are great. Some folks have heard my ramblings in the past about numbers are great, but numbers by themselves aren't that interesting. It's when you look at the patterns in the numbers that actually might tell you interesting things or help you understand bigger patterns or help you be able to compare things. And so plots are giving us visual ways to see those kinds of patterns, right? What else do you think, or what does anyone else feel about that? Why should we have plots, graphs, charts, all the above?
Does anybody else have ideas or want to share? Why might plots be a thing we want to have in our journals? And I believe
Maybe
oh,
maybe
yes.
because it's easier to see than and visualize it than just looking at the numbers.
Mm-hmm. A list of numbers. I don't know what that means.
Definitely seeing the visuals. I love that with plots, it's sort of an words, pictures, and numbers all in the same move. Ooh, and Kirsten is saying it makes us slow down a little more when looking at data we've collected. Nice. Very nice. What else? What are some other reasons? Are there any other reasons folks can think of?
Or reasons not to.
Or reason not to?
What kinds of phenomena and comparisons lend themselves well to plots? That's a great question. And Jim's asking for a definition. Oh, one of the hard questions.
What is the definition of
How would we define a plot in general? I think a plot is plots and graphs, charts are sort of a general category of things, and there are different kinds of plots which we would like to talk about. That's kind of, I think, part of our plot for today, was to kind of just like go over some the basic and common types of plots and what they're useful for, and and how we can create them and how to interpret them. Yeah, how would you, or shall I take a stab at what's the definition of a plot?
I can try, and then I'm going to pass
All
it
right.
to you. I would think of plots as being a way of organizing numbers that lets you see them in relation to each other as a whole in a visual way. What would you say, Susan?
I think that's great. I would make one little change, which is to say a way of organizing data.
Ooh, okay.
That helps us to see the connections and relations between them, or to see the patterns in the phenomenon. The reason being that data does not always have to be numbers, and in a lot of cases, numbers are how we collect or describe our data. But we'll talk about some other options.
Yes, we will.
So, there we go. Don't quote me. Don't quote either of us on that definition. So, yeah. What do you think?
I've cheated and looked it up on Google because we all know what a plot is. Why? But
sometimes the things that we all understand are the hardest things to find a definition for.
A plot is a graphical technique for representing a data set, usually as a graph showing the relationship between two or more variables. So for a proper plot, it's not just a graph, it's also ideally showing relationship between two or more variables. I don't know if that's essential. I would think you could plot one variable, but this is Wikipedia. Yeah. Who can trust them?
Well, I think that's interesting because I think so. We're using the words plots and graphs and charts kind of interchangeably right now, or we've been. And maybe there are distinctions between those words. I would say one of the types of plots we would like to talk about does specifically allow us to look at the relationship between two or more variables, but we'll talk about two variables. But there are a lot of other types of visual displays of data sets, by whatever term we like to call it, that only involve examining one variable. And so we'll talk about that too. But I think the word variable is sort of interesting in this context. So yeah, but yes, thank you for that definition. I think our plot today encompasses a number of different types of things, whether they should be called plots or graphs or charts or simply visual displays.
And I'll also point out that this is just a starting point, because we'll talk about a few types of common plots, but this isn't the end. And as we go on, we might find increasingly more awesome ways of visualizing data, including non-standard ways. So this is just a start, but it's not meant to limit us. It's just meant to start us off. So should we go into our first activity that involves the chat, or?
Yeah.
Okay. All right. So here's where we start to interact with this idea of plots. So there's a scenario that we've come up with. I'll let you say it because it was.
Well, why don't you go ahead, because you're kind of.
Okay. So okay, let's imagine that we have a field of sunflowers. And what we would like you to do is to write into the chat, if we were in that field of sunflowers, what sorts of aspects of the sunflowers would we want to investigate about each of them? Like if we were just going around looking at all the sunflowers being like, oh, what's interesting about these guys? What sorts of things would we want to pay attention to with each of them? What sort of traits? And that can be, the sky's the limit. There's no limit to how many things you can mention.
So just what characteristics, traits, aspects of those sunflowers might you want to gather data on or investigate? Let's go ahead and put in the chat.
Ooh, I liking Amy's. How tall they are here on this hill versus how tall they are over in that swale. Yep, so we're seeing heights.
Now I have to ask, what are the swales?
Oh, swales are these awesome little ecosystems where you have a bit of water in the middle, at least from what I've seen. Maybe other people have different swales, where you have a bit of water where the water table always has just a bit, but then it rises and falls during the rainy season. So it's sometimes there, sometimes not there, and rises and falls. It usually has always a little bit at the very least. At least that's as far as I know. Oh, I'm seeing some really good ideas in here. Tallest and smallest, how tall is each one? Seed productivity, are they thriving or not? What else is growing around them? How many petals on the ray flowers? What is around eating the seeds, bugs, birds? Date from planting to maturity. Bloom stage, budding, blooming, going to seed. Possibilities, plant height, diameter flowers, number of petals, color of petals, number of leaves, pollinator visits. Are there other beings interacting with them? These are wonderful. These are going so good.
Swale could be a dip in the ground that holds water better sometimes than hill would. That makes sense. That sort of seems to fit with your definition.
Yeah.
Age, height, color, intensity of color, like that. Location towards sun, like what direction it's pointing.
What type of soil? Awesome. So that those are some interesting possibilities of the kinds of data we might want to collect. Are they moving with the sun?
Yeah. The angle of something, like the head of the flower to the stem, like that. Is it pointing straight up? Is it tipping a certain direction?
So all of these different aspects that y'all are writing in the chat, there's a word for that. And it might sound like a scary word, but it's not, like, because we've just been
Well, it's already come up once in this conversation.
That's true.
Sorry, go on.
And so what is the word?
Well, so so for a statistician, we would call these all variables.
Yep.
And we don't necessarily mean variables like in algebra, you know, x equals 5 or whatever. A variable is just any characteristic that you could measure or observe about individuals of a population. So population in this case being all the sunflowers that are in this field. And that includes things that you could measure with a ruler or a scale or something that give you a numerical, or that you can count, like the number of petals of the flower, that give you a numerical value. But that also includes things that you can observe that don't have a numerical value that fit into categories, like what color is this sunflower? Is it you know, red? Is it yellow? Is it white? And that would be called a categorical variable. So it's often really useful when you're looking at data that you want to collect about a large, you know, number of individuals, to think about what are the things that I'm observing, what are the variables that I'm studying, and which of those are numerical variables and which ones are categorical variables. And the categorical variables are just as useful as the numerical variables, which is why I didn't want to place too much emphasis on the numbers too early. So we are thinking, we're starting to go through, look at some of the suggested variables that you guys have put in the chat, and just classify those things as categorical or numerical variables. And let's see.
And we would like, as we name each of them, we'd like you to call out which one you think it is, numerical or categorical.
Yeah. So we have Amy saying how tall they are on this hill versus in that swale. So I would say to find that out, you'd want to measure the heights of the individual sunflowers, right? So height is a variable.
So is that variable numerical or categorical? Numerical. I'm saying star saying numerical.
Numerical. Yep. Okay. See, don't panic. It's easy. Now let's see, we have from Lydia, we have the tallest and the smallest. So that's really interesting. Is that something that you're going to determine for every sunflower that you look at? If you want to find what's the tallest sunflower, what's the smallest sunflower, you're not going to get an answer to that question from every sunflower. You're going to have to look at all the sunflowers, collect all your data, all your values of height, and then you can figure out which one's the tallest and smallest, right? So this is fun because in statistics, we would say that question, the tallest, like what's the tallest height of all the sunflowers, is not what we'd call a variable. We'd call that a statistic, because it's a value that you can compute or determine by looking at your data set. So if you look at all of the numbers, all of the heights that you've measured for all those sunflowers, and you can work through that data set and figure out by a certain process, figure out this number, okay, this is the highest height that I've seen, that's called a statistic. So that's fun. Just a side note, there will not be a quiz. From Lisa, we had how tall each one is. Looks like we talked about that. How many bugs are on each one? So what kind of variable is that?
And you can type, but you can also unmute and say out loud if you'd like. I think people can unmute.
And just to note, by the way, I did when I mentioned about the tallest and the smallest, that was Lydia's suggestion. That's not, I don't mean in any way to say that was like not a good answer. That's a great answer. I think it'd be a really interesting thing to find out about those. And it's especially interesting because it gives us the opportunity to talk about variables and data sets and statistics that you get from them. So that was great. So yeah, so how many bugs are in each one? Is that numerical or is that categorical?
I'm seeing folks answering that it is numerical.
Good. Okay, next one, seed productivity. I think that's, are we getting any answers? I'm looking into the chat, so are we getting any?
And I'll check, and I'm checking the end of the chat. I'm seeing folks saying numerical.
Yeah, it makes sense. I think it would come down to how are you measuring, right? Like, because I think you could very easily say, well, this one's got no, these have like no seeds or like some seeds or lots of seeds, which is not very numerical, it might be easy to measure. But I think you could very easily have a more precise measurement, like how many seeds it produces or what's the weight of seeds it produces. So there's some fuzziness in here, which is fun. Star suggests, are they thriving or not?
So numerical or categorical?
So if you think about what are the possible answers to that question, like if you're measuring height, what are the possible answers? 20 centimeters, 4 meters, 16.2 meter. No, that'd be an absurdly high sunflower, but you know, I don't know, 16.2 decimeters, right? So for height, the possible answers you can get for that are numbers, right? If we're looking at sunflowers and saying, is this sunflower thriving or not? What are the possible answers?
Lisa is saying, I think we have to define how we measure thrive, which might help to have numerical data.
That's a really good point. I would think that, like, sort of boiling it down to its simplest, I think if you came up with a way to saying what counts as thriving, I would say your answers are yes or no. But you might decide that by coming up with some more specific numerical variables. But the yeses and nos, those aren't numbers, those are categories. In fact, that's something we call a binary variable, because it's got two possible answers in binary. So, but that's categorical. And yeah, there's fuzziness in this, right? Like it comes down to what choices are you making about what to study about these and how to decide what counts in one as answering the question you're trying to answer. So there's not necessarily a right answer or wrong answer. Let's see. Let's jump ahead a little bit. From Amy, we had how many petals on the ray flowers?
So is that one numerical or categorical?
If it's how many, it's probably
Yeah, numerical.
right. Okay. What's around eating the seeds? Bugs, birds?
So yeah, that question right there. What is around eating the seeds, bugs, birds, etc.? Is that one numerical or categorical? I'm seeing Lisa saying categorical.
I think so.
Star is
And again, one that would be hard to kind of pin down exactly how you're going to measure that or observe that in a clear way, but you could kind of decide how to do that. Right?
and Star is asking, couldn't it be both?
Could be. I think the real question would be to kind of come up with a more precise thing to measure, right? Like you could say, how many bugs do I already had a question? How many bugs on this one sunflower? And that'd be really cool, right? Or if you just said, okay, of all the critters that I observe on this sunflower, let me just decide, like, let me categorize them as bird, bug, bat, squirrel.
Amy is saying categorical if you're asking what's around, numerical if you're asking how many of each type.
Yeah. So I think one of the really useful things about, like, when you're thinking about what question am I asking, it's kind of a metacognition question, right? When you're thinking about what's the variable that I want to study, what's the thing I want to study, and decide, is that numerical or categorical? Those are both valid and useful types of variables to study. And thinking about it might help you realize I need to pin this down a little more precisely. Sometimes thinking about it might make you realize I need to be more specific about what I want to study so that I can actually get some data. And you can make a choice of, do I want to study something where I'm saying how many or how big? Do I want to study something where I'm saying, what is it? What kind is it? And let's see, so yeah, so from Jim, we had date from planting to maturity. So maybe that would be 2 dates. Like, what date was it planted? What date was it mature? dates are sort of weird, but generally would be thought of as numerical, right? And certainly the amount of time between planting and maturity is, whether that's number of days or however you measure it. Do we want to keep going with this, or do you want to move on from and talk about what the point is of all this?
How are folks feeling? Thumbs up if you're good and want to move to the next point.
We got so many suggestions that
And then thumbs up if you want to practice some more. I'm not seeing any thumbs up about practicing more, so I guess we're good to move to the next point.
okay. Excellent. I wasn't expecting to get so many excellent answers. That's great. Yeah.
So those are just some ideas there. And so then we're including that because it kind of helps to think that not all graphs have to be about numbers, and that a lot of times, actually every time, the graph will depend entirely on what question you're asking. Like Amy Sides points out about sometimes you have to ask what's here before you ask how many. So the first thing you do is, instead of worrying about the graph and all of that, focus on your question. And then from there, variable might be like a word that seems very mathy, but think about that as characteristic or trait. What trait are you measuring, and how does that, and also under what circumstances, I think. So thinking of it like that will help, because once you know the question, then it's about finding the right method of investigation that will help you with that, or the right graph. It would now be a good time to do my demo about dates really fast, and then
Yeah.
okay. So a bit later on, we're going to be doing something where we get to play with data. But first, I wanted to give a demo because I think that it will be helpful just to see, like, if sometimes I look through my notebooks and I'm like, oh gosh, how do I do all of these numbers? And so I'm going to show you a really easy exercise that can kind of get you into the graphing mindset. Just give me a second to set myself up for success. I'm going to move this computer here, and I'm going to turn on this camera right here. Okay, there's that. So one thing that I was doing the other day that was really helpful to me was that I thought, well, what are some numbers, because I was worried about numbers, that I commonly write in my nature journal each time that are not that hard to do? My answer was dates. So I thought, wouldn't it be interesting if I were to look through my nature journals and see how many dates in a month I went nature journaling? So I'll demonstrate how we do that. Pretend that I'm starting, and I won't do the entire year. Let's pretend that I'm starting with, where is it? Oh, okay, yeah, here we go. Goodness. Let's pretend that I'm starting right over here with January.
Sorry, if I may interrupt, it would be good to unspotlight me so we can see your screen bigger.
Okay.
I don't think I have that tool.
Okay. So I noticed that I'm fairly consistent about writing in the dates, not always, but fairly enough. So suppose that I wanted to turn that into a graph. In this case, I'm going to make this into a bar chart just for this time. So I'm going to start, wait, is this backwards for people or no? Let's see. Tell me if this is backwards. So I'm just going to start like this. And I'm going to say that this is about, okay, this will be for January. And so what I would do is on this axis, on this part, this would be month, each month. And going up here, this would be the number of dates in that month. So what I would do to count this is I would look through my nature journal. So if I see Thursday, 11th of January, then I count that as being 1. So that's 1 date. And then I might flip through my journal. Let's see here. And then right here, I've got the 30th of January. So that would be another date. So I'm just going to make that a 2. and I'd flip through it again. We've got another January date. And so that's my 3. And then looks like that's all for January. So then I'd move on to February, and it looks like I've got February 8th in here. So Feb is there. Oh, and then for some reason it jumps to, oh yeah, wait, that was earlier today. Ignore that. And then, oh, it looked like I really didn't do very much journaling. So then I guess I would go with March, and so on and so forth. Now, instead of making you watch the whole thing, I'll show you what that kind of led to last year. In the end, I would wind up with something that looks, let's see if I can, okay, let's see if I can get this. I would wind up with something that might look like this. This was from 2023. So I looked at each month, and each box represented a different date. And so in January, on 10 different dates, I went nature journaling. February, it was 9, and so on and so forth. And this could be, and then, this could be interesting. I wrote down my question up here. Sometimes writing it down helps so that then you know exactly what you're asking. And from here, maybe I ask myself some questions about process. Oh God, is it not focusing? I don't know how to make it focus. Okay, there. So I might say, like, doing this will actually give me some insights about things that I don't know. And so I might ask myself while doing this, what about dates where I nature journaled more than once? Do I count those twice, or do I only count those once? For example, maybe I'll ask myself as I'm doing this, what counts as nature journaling? When I'm taking notes in class, do I count that? Do I only count it when I'm out in the field, et cetera, et cetera? And so I ask myself these kinds of questions. What about pages where I neglected to write down the date? And so with these are questions that come up as my process, and it's okay that these came up. The data doesn't have to be perfect. Instead, what I might do is I might also include, if I want to, what my answers were to these. Like maybe I said, I chose to only do the date once. Or I might say I chose to do everything in my journal, or I might say there were approximately blank number of pages with no date. So that's a process question. And I like to separate that out from an interpretation question. And the interpretation is about the dates or the data itself. So I might ask myself, why did I journal the most in September? I mean, that's kind of notable, don't you think? So with that one, I might make a why web for myself to do that. In this case, I think I know the answer. I think that it might be because there was a certain Wild Wonder event happening that month. But let's pretend that this isn't about me and my dates. This is about something else happening in nature where we don't have the ready answer because, we don't live in the mindset of that creature or that plant or that probability. So the thing is that then from here, if we ask, why is this such a high number? That's when we might lead it to a why web for funsies. Or I could say to myself, am I journaling more or less or the same as I was last year? And then from there, why? And so that's how you can have dates here. And like, sorry, that's how you can have data, but the data doesn't have to remain just in graph form. It's a thing that you can use to interact. It's an investigation because doing this will give me more questions. For example, I had this assumption that I had a huge drop in February of last year because of something that happened that month. Instead, I learned by looking through my data that it actually wasn't that big of a drop. It was only once of a drop. And that my lowest time was surprisingly here. I thought it would be the summertime. So data is also a really good way of testing your own assumptions. So that's my demo for that. And I say that one because then if you have people who are kind of math reluctant like I am, then doing this is a really simple just way to practice doing graphs and data. So that is that. Before we continue to our next part, are there any questions about what I just shared? I'm not seeing any. Is that making sense to folks? Okay, cool. So then, oh, I'm seeing something in the chat. Okay, cool. So then Susan and I will move to our next part.
So I think our next thing we'll look at was to just have a kind of a quick look at some different types of charts in general and what they might be used for. And then with that in mind, then we'll sort of go on to do another exercise from their example.
That's
So,
right.
had
Here's
something prepared for that.
I will do that. This people don't like, nobody has to print this or anything, but we created a little just a little paper to or a handout just so that way we could sort of see examples of graphs, because then that way it gives us ideas of how they differ from each other. Just because then that way we think if we have certain I'll make this a little bit bigger for folks so that it's not, we're not straining our eyes. That way we can think about how each graph might demonstrate what we're learning or what we're studying a little differently from each other. So that's why we are including this part. So again, these are not exhaustive. There are lots more charts and plots and graphs and et cetera out there. But for example, there's pie chart. And pie chart, that's a question that is about proportion and things being relative to each other. So pie chart assumes that there's a 100% of what you're measuring. And so we're saying what proportion, for example, suppose that the pie chart, the question here is, what types of birds am I seeing? And I've gone and taken some data. Some of them are, some of the birds I'm seeing types are, because I'm looking at what birds, what their nesting types am I seeing. So I'm seeing some are cliff nesters, some are cavity nesters, tree nesters, shrub nesters, and ground nesters. So I'm
really important point to, sorry to interrupt, but what kind of variable is that? So you're looking at your birds, right? And each bird, okay, that bird's a ground nester, that bird's a cavity nester, that bird's this kind of nester. What kind of variable is that? Lisa says that's a categorical variable, which is really important because pie charts specifically get used for categorical variables.
Yep.
So, sorry, interrupt, but carry on. This is a great example.
Oh, no, thank you for interrupting. Like that's an excellent point to include. And so in this case, of all of the birds that I observe in a day, I'm noticing on this particular day with this particular data that we can easily see here that the majority of the birds that I saw were tree nesters, or at least more than everybody else. And then maybe the second most common type of bird I saw were ground nesters. And then from there, we had cavity nesters, shrub nesters, cliff nesters. So this says here, this tells me that the least common type of bird I observed were the cliff nesters that day, and the most common were the tree nesters. And that helps me relate these to each other in a really, really easy way visually. But if I were to look at that same data on a bar chart, this tells me numbers, actual hard numbers. It doesn't necessarily say these relative to each other, although you can see that the tree nester here is quite a bit taller than the others. You don't know the exact percentage of the whole are tree nesters, but you can say that you observed 15 birds that were tree nesters because the number 15 is right here. And then we could say, for example, that 8 of them were ground nesters, that I guess that's 3 of them were shrub nesters. So these will give you the actual numbers, but not necessarily in proportion to each other. Does that make sense about how those two are a bit different from each other subtly? How often do I see this versus how are they relative to each other? Okay. Do you have anything to add about these two first examples, Susan?
Yeah, well, I think let's say I think the bar chart is probably the more intuitive type of chart to create from that data. I was also going to responding to the chat here. Hold on a second. So technically, the data here would be just like if you were measuring all of the heights of all the sunflowers in the field, you could have a data set, which is a list of numbers, right? 1.2 meters, 0.8 meters, 0.85 meters, etc., right? If you're looking at the birds, you could make a list. You could say, okay, tree nester, cavity nester, tree nester, ground nester, tree nester, cavity nester, and you just could have a list, and every bird is giving you a data point, right? So that's actually what your data set looks like, is just a whole bunch of answers, which are all the different categories that it could be, right? In creating the chart, you are consolidating those. So now what you're doing is now you're counting how many observations I had in each category. And so that's why I think the bar chart is kind of the more intuitive starting point for displaying that data, because you can take each category that you have, and you count the frequency of observing that category. So the height is telling you how often did I see this possible value of the variable? How often did I see a ground nester? How often did I see a tree nester? How many of my data points fit that category?
Yep.
The pie chart, as you say, I think you can take those raw numbers and then turn that into what proportion, what fraction of the whole is that. So you're doing a little extra work to get the pie chart. But there's a question about what's the difference between a histogram and a bar chart. Kirsten says histograms are numerical data, not categorical, which is exactly right. Traditionally, histograms don't have gaps between the bars, and categorical and bar charts do. So this is demonstrated in the diagram here, where the bars are all smushed together. And the idea of the histogram is actually doing the same thing, right? The values of the variable in your example are mustard taproot lengths. So length, that's a numerical variable. And you've measured all these different taproots and you've gotten lots of different lengths. And now what you're saying is, instead of saying how many of my data points are ground nesters, you're saying how many of my data points are between this length and that length. And I can't quite read what the lengths are, but
5 centimeters and 13. So
okay.
7 of the taproots that I measured have taproot lengths that are between 5 centimeters and 13 centimeters. Why that? Because then listing out, I guess that the other way to do it would have been to say 5, 6, 7, and then to have however many go up like this. But instead we're saying this is a range.
Yeah.
And then from
You're
there,
smooshing the numbers together in a way that lets you see, right? So the heights are actually accomplishing the same thing in both kinds of charts. They're saying how many of my data values sort of are in this particular area of the possible results, right? And so how many of my data value, how many of my taproot lengths are between 13 and 21 centimeters?
Yep. And that
how
would
many
be
are between
21 and 29.
Mm-hmm.
And so with these ones here, this is about range. The one that people might think of, though, when they think of entering in mustard taproot lengths, might be something more like this, the scatter plot. Although in this case, it's comparing two things. And I might have done this wrong. The x-axis here is the length of the root. So in here, we get the individual values. Right here, we have, for example, oh my gosh, it's hard to read because somehow this isn't correct.
You can zoom in if you need to, but I think the key point of the scatter plot is the scatter plot specifically. That's when we get into having two different variables that you want to look at.
Mm-hmm.
So if you were only looking at mustard taproot lengths, you wouldn't use a scatter plot because the taproot length is just one variable. You would do other things to understand what's the pattern, right? Like looking at your histogram, the pattern there is that most of your taproot lengths are kind of on the low end because you have high bars there. And just a few of your taproot lengths are longer and therefore they're at the high end of the range. You'd use a scatter plot specifically if you want to look at two variables and ask, is there a relationship between them? So yeah, then the two variables in this case are number of clusters of flowers versus taproot length. But sorry, carry on. Sorry.
Oh, no. I'm going to add that to this because that'll help it more. Is there a relationship between these two variables? And so in this one, you know how in statistics we say correlation is not necessarily causation, or maybe it's the other way around? In this case, we're saying, is there a relationship at all between these? And I know that there are some ways that statisticians measure to determine if there's a relationship, but if there isn't a set pattern in the data, then perhaps there isn't so much of a relationship.
So in this example, If you kind of squint your eyes, could you imagine drawing a straight line that more or less kind of went through those points where there's like a line, there's sort of a line that kind of like best fits the data that you could draw without going through every single point, but it's just kind of like in the midst of the scattering of the points. Oh, put it me. Here's a different question. As you look at points from left to right, right? The x-axis is the taproot, right? So points that are farther left are points that have a shorter taproot. Points that are farther to the right have longer taproots, right?
Yep.
Do the from your observations there, do the plants that have longer taproots have, of those observations, have they generally had more flower clusters or generally fewer flower clusters, or is there really just no pattern? Like as you move from left to right through those points, is the number of flower clusters generally going up? Who can add in the chat, or they can speak up, or Yvea can. Yeah, Kirsten says, yeah, I think that's so, right? There are some exceptions, like there's that one that's kind of near 30 taproot length, where the number of flower clusters is a lot lower than the ones that are to the left of that. I wouldn't call that an outlier, but certainly it's unusual. But for the most part, you're kind of working as you go to the left, you're also going up in those through those data points, right? So, and I think you could draw a line, a straight line, that kind of goes through the middle of those data points. Doesn't fit it perfectly. The points aren't on the line, but you know, and there's other lines you could draw that don't go through, that are bad, that don't fit the data, but there's one you could do. And that line, because it's going up and to the right, we'd say it has a positive slope. And as Sarah said, there's a positive correlation.
Yep.
So in general, as the taproot length increases, the number of flower clusters also increases.
Yep.
That doesn't mean that having a longer taproot causes there to be more flowers. It could be that having more flowers causes a longer taproot or something else entirely. But it does mean that there is a correlation there.
Yep. Does that make sense to folks? And then, as we mentioned, there are also many other types of graphs. I didn't have time to make them, but then there are things like radar graphs, there are infographs, the whole one where you like see 10 little stick figures standing next to each other, and one of the stick figures is a different color than the rest. And then we say that 1 out of every 10 people, I don't know what the statistic is, but you get the idea. Like that's an example of what an infograph might look like. And then we have the radar graphs where you're kind of overlapping different traits. That's a bit more multivariable. I'm going to stop the share here. So those are just some examples of graphs. And as you can see, a lot of it depends on what question you're asking. So that's really what it is that once you find out your question, then you get to figure out which graph is going to best help you examine it and be creative.
Yeah, and I would add, and specifically, what kind of variable and how many variables, right? So if you can look at the question you're asking and determine, okay, am I collecting data that's numerical or categorical? And am I collecting 2 or more variables? Then I'm going to be able to use a scatter plot for that if they're numerical. If they're not numerical, then it's a little hard to do. If I'm collecting just 1 variable, then I'll use other kinds of plots, and you know, bar charts and pie charts are great for just looking at the distribution of categorical variables. Histograms and other related types of plots are useful for looking at the distribution of a single numerical variable. So yeah, so really I think like the question you're asking, and then looking at how many variables and what kind of variables helps you decide what kind of plot would be useful for.
So if that makes sense to folks, then we were thinking that for our next part, we could do some practice if folks are interested. Susan has been collecting some butterfly data. and we wanted to let people play with it a bit.
Yeah, so I was out at my beloved Albany Pine Bush, watching the butterfly weed, which is well named, also known as orange milkweed. And I'm always interested in looking at the feeding patterns of the different kinds of butterflies that are on there. And everybody loves orange milkweed. They all come to it. So I started keeping track of what kinds of butterflies were on the orange milkweed. And so here's what I came up with. So I could note down all the different species, but I can't always tell the species, so that's my excuse. But also I wanted to just sort of categorize them as like what family of butterfly are they? And so I was just, I took notes here, and so I had two swallowtails showed up, 4 Pierids, that's whites and sulfurs. Lycinids are the blue butterflies, hair streaks. The coral hair streaks go absolutely nuts for this stuff. They're just all over it. And coppers and things like that. They're little butterflies. Nymphalids are brushfoot butterflies. That includes monarchs, fritillaries. You guys in California have your admirals and your sisters and all those guys. There's lots. It's a huge family. So then there were, I think we had about 8 for those. And then your skippers, and I despair of ever telling skippers apart, but at least I know a skipper when I see one. We had 5 of those. So I had that data, and the question is, how should what sort of chart or graph could we use to graph that or to display that? What would make sense for that sort of data?
And folks can answer either in the chat or they can say out loud if they'd like. What kind of chart can we use for this?
We can have some discussion, because I mean there might be multiple different ways of displaying the data, and you can decide what one's best, or do more than one. If we do that. Bar chart, pie chart, good. Of course, this is categorical data, right? That's orange shadow here. Yeah, because each butterfly is a certain type. It's just like the bird nesting strategies, right? It's each bird, you can categorize it in a certain category. Each butterfly can categorize into something. So we could do a pie chart, and we could do a pie chart or a bar chart. Maybe we do both. We can do it fairly quickly and not. Oh, Star, I'm in your area. I'm in Albany, so if you're also in the general area, we should meet up. But we'll discuss that later. Yeah, so we could do both. And I think a bar chart, as I said, I think is a little more sort of intuitive and a little, I think, quicker to make quickly. Okay, too many distractions. Kirsten, you're suggesting to use the butterfly colors you stated in. I love that. But I will have enough space here. I could do a bar chart and a pie chart, which was my secret plan all along. So yeah, I might do that. So I would suggest Yvea's put the data in the chat. Do you want me to demonstrate on camera how to do it, or folks just want to give it a go on their own?
I'm seeing folks requesting for demo, please.
Okay. Yeah. I think that'd be good, because the thing about a pie chart is that it can be a little tricky to work out how to make the pie slices of the pie chart. So I've turned my hash marks into numerical values. They also added that in the chat so we can see. So for just a bar chart, all I need to do, I'm gonna, just like Yvea did before, I'm just gonna make myself a vertical axis and a horizontal axis after I move something else out of the way. Excuse me. So all I did was make myself a vertical and horizontal axis. If I had a little more room, I would make it bigger, because making it big and readable is always good. I always tell my students to write big so I can read it, but here I am ready for a smell. And so with a bar chart, I want to put my categories along the bottom axis. So butterfly family, basically. So I might try to abbreviate that because I don't leave a whole lot of space here. So I'm just going to mark maybe ST for swallowtail, in the hopes that I know what I did. I'll also, of course, label my axis butterfly type or butterfly family. And I'll make a mark for each one. So maybe I'll put a P for period. I think this should work. N for an invalid. Oh, I missed lycinid. So I'm going to put L for lycinid. And I'll put H for Hesperiid. And I just realized I've forgotten the family for swallowtails. So swallowtails get to be in non fancy scientific name. So there we go. There's my chart. Maybe I would prefer to space it out a little more, but not a big deal. And what I want to do is I'm going to look at this thing. Okay, what's my highest number? My highest count is 14. It's hard to cut things into 14 equal pieces, but if I cut things it's easy to cut things into 3 equal pieces. So maybe I'll mark my highest point on my y-axis, which is going to be frequency. Frequency meaning how frequently did I see that category? Maybe I'll put a mark for 15. Papillion day. There we go. Thank you. Too late now because I made ST already. But yeah. So frequency. Maybe I'll make this as 15. Just because I can cut that into thirds relatively easily, and I can have 5 and 10. And I really wish I'd left a little more space here, but hopefully you can see where I've got my 5, 10, and 15. Depending on how precise you want to be. Honestly, I'm a big fan of being kind of sloppy in my nature journal because I've got the data. I'm just, I'm not interested in spending a whole lot of time making super precise graphs. We do have computers to do that. I might not bother to make the extra little hash marks there for the individual numbers. But what I'm going to do then is I'm going to make a bar on top of each category where the height corresponds to the frequency. So for swallowtails, that was 2. So I have not marked 2 on here, but I know that 2 is a little less than half of 5. So I'll make a little bar above the swallowtails. That's a little less than half of 5. That is 2. And maybe I'll paint that with a color that I paint the swallowtail later.
Could you hold it a little closer to the
Oh,
screen?
I'm so sorry. I'm trying to hold it without the light, with the light being able to be visible.
Can folks see that? Okay, good. Awesome.
And for periods, I had 4, so I'll make that one twice as high as the 2, but not quite as high as the 5. Traditionally, there would be a gap, a space between the 2 bars because this is a categorical variable. Now, this is like Bob Ross. This is your nature journal. This is your world. If you don't put a space between your bars in your bar chart, the math police are not going to arrest you. It's fine. If you make a histogram and you do put a space, it's fine. The purpose of our charts is for us to understand and get a better understanding of our own graphs. It's not for somebody to grade you on whether your chart meets the standards of whatever the American Statistical Association has said that chart or whatever, right? So I'm conscious of putting a gap here because to me, I know what that gap means. It helps promote my understanding by knowing that my categories don't run together. Right? There aren't things that are kind of like almost swallowtails, but kind of periods. There aren't. So having a gap there sort of is meaningful to me. But it's not like there's no one's going to arrest you if you put a gap or don't put a gap. It's really the whole point of all of these charts is for you to help you understand your data better by being able to look at it. So whatever helps you do that is great. Now I swapped the order of 2 of my things here, so I'm going to put nymphalids next. That's 8, which is conveniently twice as big as the 4 that I just had, but not quite as big as 10. So I'll put a bar for 8 for nymphalids. I will put, my next one is lysanids, which was 14, so that is almost as high as 15. Those coral hair streaks, man, they're tiny and they're little and kind of brown. And they just love the orange milkweed and they just will not be swayed from it. They're the most skittish of the butterfly, of the hair streaks that I know of. They won't let you get close with the camera, but they will do anything for orange milkweed. And let's see, my skippers, I'm not going to try and pronounce that. 5. And here's my little bar chart. So what I'm seeing now from looking at this, like we could have maybe seen this from the numbers alone. What I'm seeing though is first of all, the lysanids are crazy. They're just like all over this. That's definitely the one that's the most popular. But there's actually like, they're not like overwhelming the whole thing. Like the nymphalids are, you know, not quite as many as them, but they're also like pretty consistently coming to this. And the other families are not so much. And it'd be interesting to compare this to how many butterflies I see of these families just in general in the area. That's really hard to get data on because some of them are present, but you don't see them so much, right? Like, you know, some of them are tiny, they fly low to the ground, you know, so it'd be interesting. And now I'm kind of want to make a little bar chart or something like that to like, what's the general proportion of different kinds of butterflies in my area? But that seems hard. So I might have to think about how to collect that data. So collecting data about who's pollinating a particular patch of flowers is easier to collect. So any questions on how we made the bar chart there? And I do like the idea of like painting in the bars. I already painted my butterflies. So if I paint the bars with the same colors that I used, then it would like really visually match up and it would look pretty. So that's nice. So how about that pie chart? The thing about the pie chart, if they have pointed out, the pie chart is telling us what proportion of the whole is taken up by each category. I don't have that information in here. So here's where we do actually, yeah, I'm going to say, here's where we do actually have to do some math. But that's a lie because we've been doing math the whole time. Here's where we have to pull out our calculators, maybe. That's accurate. But computation is not the same thing as math. Math is the thinking part. Math is the part that's going on in your head. So we've been doing math the whole time secretly. Or not so secretly. Okay. But so how are we going to figure out I want to make a pie chart. Maybe I'll grab something circular. I happen to have these little cedar discs to fend off the moths. So I'll make a little circle out of that. But I need to know how much to divide up the circle for each category. So how do I go from the raw numbers to that information? Here's my circle. What you want to do, you know, so it's fairly easy to just kind of eyeball it and like cut circles into various fractions. Like I can cut half a circle. I can make a quarter of a circle. That's pretty easy to do just by eyeballing it. We could take a protractor and make it more precise, but honestly, like I said, like we've got computers if we want to make like really nice pie charts. I'm not really interested in going to a lot of effort to get my angles like exactly perfect here. I can estimate well enough for that those wedges of my pie chart to look good and tell me something. But I have to know how to do it. Chris says total, then fractionate. I love that. And I'm imagining a Dalek going fractionate. Sorry, bad Doctor Who joke. Yeah, so we need to know what's the total number of butterflies that I saw. That's easy enough. We can add them up. So my total, we had 2 swallowtails, 4 apirids. That's 2 + 4 is 6. had 14 blues. You can use a calculator, it's okay. Or count your fingers. But they will, right? I had 6 swallowtail periods. I have to add 14 lycaenids. If I add 1, 2, 3, 4, that's 10. And then another 10, that means 20. And then I have to add 8 pallets, that's 28, and then add 5 skippers. So that's 33, I think. You are allowed to use a calculator or do it on your paper or count with your fingers and get your friends to add their fingers in, whatever you want to do. You don't have to do it in your head. I have fun doing calculations in my head, so sometimes I do, and then that freaks people out, so I apologize. Yes, so total is 33 butterflies. So we want to know what fraction of the circle is each one. So that's easy enough to do. We can take our calculators and figure out, okay, I'm going to take the biggest one first because that's usually the easiest to work with. And I think is going to have the best chance of us having a pie chart that splits. I'm going to take the biggest one first, biggest category, which is lycaenids, 14 out of 33. Unfortunately, I said I was pretty good at cutting circles into fractions. I don't know how to cut a circle into 33 equal pieces, and I don't want to count 14 of them. So yes, Yvea says slightly less than half, that's my jam. Right? 15 is half of 30. 16 is half of 32. So 14 is a little under that, but of a bigger denominator, so it's a bit less than half. That is good enough for me. I am not going to try and make it better. If anyone wants to talk about how to make it more precise, we can talk about that in a moment, because we absolutely can do that. If you've got a protractor or anything that can measure angles, then we can make as perfect of a pie chart as you want to. But I am going to cut my pie chart into slightly less than half and be happy with that. There you go. Good enough. It's probably, maybe it's a little under, I don't know, but this is our lycaenids. If I can spell it. And then Yvea says infallids at 8 are slightly more than half of the fraction that's left. I love this, like more than half of the remaining thing. That's excellent, because that's I think it's easiest to cut things in half. So I can easily cut the remaining portion of the circle in half. I would just go right through there, but then I'll just bump it up a little bit and make it slightly more than 1/2. Love that. So that would be our infallids. And this is something I would definitely paint in the wedges in the colors that match the butterflies. I picked one example of each one. Obviously, there's lots of different colors of butterflies within these categories, but color coding is nice. But yes, I did paint them specifically so that we'd have colors that we could use. And yeah, so that, and then actually, then the other ones are actually, I didn't do this on purpose. Well, but the Pierids are half of infallids. Hesperiids are slightly bigger than that. And the swallowtails are half of the Pierids. So oops. Looks pretty decent, right? I'm just aiming to get these kind of generally in the right proportions. And what you definitely could do is you could take any of these numbers here, take the swallowtail, that's 2. Take a calculator, divide that by 33. And you're going to get somewhere around 0.06, I think. Right? So if you want, you could try and estimate, okay, what's 6% of the circle? Sometimes it's if you find percentages you're easier to work with, then you can do that. And there's lots of different ways to do this, but I think this is good. Any questions on how we do this? I definitely could and would fill in the colors here, but just for the sake of time, I don't know if it's a good idea to do that. But does that kind of make sense how we go about this?
I'm seeing nods.
Okay. So yeah, and I don't know. Jack's not here, so we don't have to please him. But I sometimes I feel that my approach to sloppy math or sloppy estimating in my nature journal, I think is sometimes I think Jack doesn't always want to do the sloppy thing. But you know what? We're here, and also I'm a mathematician, and I say you're allowed to be sloppy. So go for it. You know. And even with just a very rough estimate here, it gives me a really good idea. So what I also have.
Can I add to something that you were saying?
Uh-huh.
To add to that, as a non-mathematician, but who really does like numbers, so I'm math curious, like I find that the permission to do sloppy math makes math more accessible to me, and that's really what it's about. It's about making this as an accessible tool. So hearing Susan do that and getting to do that and be like, yes, this is fine, and we still get an approximate idea of what's going on without having to crunch a ton of numbers, it puts the fun back in math for me. You know what I'm saying?
Yeah.
Um,
Yeah.
and
I
so,
mean, these are just tools that you can use. No one's forcing you to use them, but you can use them, and you might get some benefit out of them. I mean, if you go to the hardware store and you buy a hammer, and you have some nails you need to hammer in, there's probably someone at the hardware store already who's gonna like tell you that you're holding your hammer wrong and you have to do it this way, and if you do it with exactly this force and this technique, you will hammer your nails in perfectly and anything else is wrong, right? But you know what? Any way of holding your hammer that gets the nails in and doesn't get your thumb is probably fine, and in the end you can build a table, and it might not be the best table that some like fancy furniture maker makes, but you can still put your tea on it, right? So I don't know. I mean, I guess at a certain point, maybe we don't build a house like that, but also don't write a scientific paper and be sloppy. I mean, there's limits. So here's the question: we have so many more things we can do, but just as a note here, I also have data from a different kind of flower. And so I thought it'd be interesting to here's butterflies feeding on common milkweed. Now, orange milkweed is related, but the flower structure is quite different. And I have noticed that we have different types of butterflies that tend to kind of congregate on it. So I thought if we want to, we could do another pie chart for the common milkweed. And the advantage of that, of course, is that we immediately have this visual comparison of the two. And I think someone up thread was talking about doing this with plants. I think this is one of the really cool things about pie charts, is like so immediately it allows you to compare 2 or 3 or more different situations, and where you're measuring the same variable in both cases. You're looking at, in this case, what types of butterflies are coming to these, and be able to see those differences, which is awesome. So, but for the sake of time, I think there's some more things we wanted to do. So I don't know, perhaps we should move on.
what do you all say? Should we go to our next thing, or should we spend a little time with this data?
And I will say, if anyone does want to look at how to make a pie chart more precisely, by actually figuring out what angle should I make this, measure it, we can talk about that. I'm not against doing that. We absolutely can do that. It's not too difficult. But I think we don't want to spend the whole day on pie charts unless we want to. So,
and so folks know what we were thinking of having next, so that what the choices are, is that we were going to send folks into little breakout rooms so that we could share what kinds of things do we ask or do we see in our students' nature journals where we're using graphs could be helpful. So what sorts of questions have we done either in our own journals or have our students done in their journals where this could be a tool to help? So I think that that's a question also that Amy asked at the beginning. So we were thinking that that could be the subject of the breakout rooms. So that's sort of what we had next. So what do folks say? I do notice that it is 1:20, so maybe we should, is it okay if I suggest that we go to the breakout rooms and do that? Because I want to make sure that we respect people's times. I think
Yeah, any question? Yeah, do we, for 11, I mean, we could do 2 breakout rooms, or we could just do one. I don't know, what do you think's better?
I think that having 2 breakout rooms might be good, just because like it's totally fine that people like for people to talk as much or as little as they like. But I noticed that when we're in the big room, people are more shy. So if we send you all to breakout rooms, you might talk more to each other. It's also okay if you don't, but I think that maybe we'll send you all to breakout rooms, and also especially because the breakout rooms are not recorded. Or if any part of them ever are, I always cut that out. So people might feel less shy if they know that it's not going to like be on the internet or something. So that agreeable to folks?
So what's our kind of discussion topic specifically?
So our discussion.
You are there.
Oh, that's a good point. It might be easier if I put the question into the chat. And then of course I have
We're basically, what are some questions or problems that you or your students are thinking about or would like to investigate with these techniques that you think that you either have ideas for or would like suggestions for using charts and graphs to help you examine. Yeah.
So I've put the brainstorm question in about, what questions you or your students have had in your nature journal outings where a graph might help you examine it. So shall I send the folks into the breakout rooms? Okay, excellent. In that case, we will create our breakout rooms. We encourage folks to talk about this for about maybe 7 minutes, and then we'll reconvene. And let's see here, breakout rooms. We're going to create 2, and we're going to say, there we go. We wish you all good discussions now. So how are y'all doing? Good. Were there some particularly interesting things that, oh, go ahead, Chris.
Well, I just wanted to say I was wanted to commend Susan. One thing that stuck out the most for me was just thinking about that the math is the thinking, not the computation. It's figuring it out, what you're going to compute and why, and looking at the world mathematically instead of just by numbers. Looking at all things. That was what I wrote down. Yes.
I agree. Lisa Grace. Oh, go ahead, Jim.
One thing that came up, well, one thing that really came up is we couldn't think of too many things except for numbers of birds. I think that was the main one that a couple of us had in common. But the idea of, and maybe Susan might have some thoughts on this, of the bar graph versus the versus a histogram or a pie chart, in that a bar graph can be kind of misleading because we're so used to X and Y axis. And I noticed this, and someone else like seconded it, that your bar graph of the butterflies really kind of look like a bell curve, unconsciously. So, maybe they can be a little misleading because we're so used to that.
That's a good point. If you saw a bell curve in a histogram, that would be meaningful.
Right.
In fact, it might well be. And in fact, the place where a bell curve is really a bell curve, like where it actually has that meaning statistically, is in the distribution of a numerical variable, which is exactly what a histogram is showing you. It's interesting because I recall a situation where I was looking at a graph someone else had showed me. It was of like numbers of Kerner blue butterflies over time from the early May when they first emerged to when they die off, and it made this sort of bell-shaped curve. And I thought, oh, that's interesting that it's a bell curve. And then I realized, well, that's actually not a histogram, but they were showing me. It's plotting a totally different thing. It's actually what you'd call a time series plot. And so it is. So it's interesting you point out that this bar graph happened to look like a bell curve. Something to note is in a histogram, if you were to rearrange all the bars, like if you pull up the histogram again, if you were to like swap the positions of some of those bars, move them left and right, would that swapping make any sense? Would it be reasonable? Maybe once we look at it closely, we can see. Or does the order that the bars go in is that actually meaningful? If we can see closely, so we can see the labeling on maybe we can zoom in even a little more perhaps, because I can't quite read the labeling on here. There we go. Yeah. So the first bar that we see is the bar that's between 5 and 13. Right? The next bar is between 13 and 21. If you try and swap those two, you're going to have the 13 to 21 and then the 5 to 13, which is nonsense. Right? Because as Amy's saying, in history, the ordering is meaningful, and that's because the variable that you're studying, which is going along that x-axis there, is a numerical variable. And so really that bar from 5 to 13 actually represents a bunch of mustard taproots that are like, one of them 6, and one of them is 6.5, and one of them is 8, you know. But the order they're in is actually meaningful. On the bar chart to the left of that, if you rearrange the positions of those bars, does that make any difference in like what it means or how you understand it? You could rearrange them, and it would be completely as good of a bar chart as it was, right? Because the order that all those different bars go in, which one's on the left, which one's on the right, doesn't matter at all, right? There's no reason why a ground nester has to be to the left of a shrub nester, right? And same thing with the bar chart that I made for the butterflies. So if you think about it like that, and you sort of ask yourself that question, you say, I'm seeing what appears to be a bell curve here. And the question is that actually meaningful?
Make a difference.
I think the question you can ask is the position of the bars left and right meaningful? Because if that is, you probably have a histogram, and what that probably means is to have more things near the center and fewer near the outside. But if it's a categorical variable, there's no reason that they have to be in any order whatsoever. And if you rearrange the bars, in my bar chart, you get a totally different shape. It does not look at all like a bell curve. And so if you can sort of convince yourself of that, if you can kind of think about that, say, well, I could rearrange the order, then whatever bell curve I'm seeing is actually not meaningful because the order isn't really relevant, and the order is what's making it look like a bell curve. Does that make sense?
Yes.
So I'm not sure if I answered the question, but this
is why, in my humble opinion, pie charts rule.
Yes.
I just think a pie chart is better.
Yes, they're very excellent. They are doing different things, and there's times when it's useful, especially for comparison. There's times where it's very useful to have bar charts to show the absolute numbers. Now,
right. Yeah.
You can also use a bar chart to show those relative proportions, but
you get more quantity with a bar chart. You get more.
So So for example, if I studied the butterflies, the butterfly weed in a half-hour period on one day where it was kind of cloudy, and then I did the same thing on a different day when it was really sunny, I saw 33 butterflies this one time. I might have seen 60 butterflies the next time. And so all of the bars for the second visit would all be higher, and I could kind of line them up and color them differently, and you could do a sort of what we call a comparative bar chart. And then you'd be able to see that actually the numbers were big. There were actually more butterflies in addition to the distribution maybe being similar or different. So there's advantages to each, I think, and I think again, I think this is why it's more important for you to look at these different kinds of charts or the data that you have and like think about how you might choose to display it and whether it is showing you meaningful patterns, whether it's fooling you into thinking that there's patterns that aren't there, and make choices about like, okay, is that something that's useful to me more so than like, oh, this is the way it's supposed to be done, because there's no way it's supposed to be done.
I see, if we have time, I see one more question from Sarah Bellis. Sarah's asking, if we have joined dots, then does that presume a gradual change between the data points?
Typically, if you're measuring data over time, so, you know, maybe you're measuring the temperature at different times throughout the day. Here's the temperature at 10 a.m., here's the temperature at 11 a.m., and so on, let's just say. That we'd call that a time series plot. And you can do that like a scatter plot. You make a horizontal axis for the time, day or year or whatever. And then the height represents what's the temperature. And you can make dots with this, you can see. And yeah, if you put a line between the dots and you go, that's it's sort of a way of representing that, yeah, like you're only measuring the temperature at specific moments, but we can presume that the temperature is like sort of gradually increasing, gradually decreasing, and that line is meant to kind of evoke that idea. So yes, Sarah, that's exactly right. I would say that that's really the key. And usually you would do that when you're looking at data over time. There's probably other situations where you might do that, but I can't think of them off the top. But, you know, again, if you have data where you think that would be a reasonable way to display it, then do it.
So was this helpful for folks, today's workshop?
Yes, very much.
So this is our discussion for today, but that doesn't mean that this is the end of our math discussions. We can continue exploring, we continue asking questions. If some of this feels like, you know, difficult to start later, that's fine. We'll just help each other out and we'll start again. We'll make this so that it's the habit of doing it over time that makes it a little easier each time. So you don't have to feel like you have to be perfect or know everything that we did today. Just play with it, the way that Jack's grandma said about watercolors. And I want to let's all give a huge thank you to Susan. That was awesome. Thank you, Susan. We are super lucky to have you. And
another huge, enormous thank you and a round of applause to Yvea.
Yes.
Because you orchestrated this, you like figured out how to organize this whole discussion in a way that made sense. You made those awesome example graphs and talked about and showed us how we can use them and what they mean. And yes, that's just.
Thank you. And you made me want to learn more about, like, you made me inspired to try this, which, you know, not every, I can't say that about all my math teachers, but Susan made me want to play with it. So thank you for that, Susan.
It's making fun. So.
Oh, and yes, sometime I'm seeing Sarah saying, can we play with international data mini projects maybe? Yes, we should do that. We should make it a thing that we do. We'll try to plan out when and how that could work out, but yes, we can totally play with international data mini projects. That's a wonderful idea. So before we go, Susan, any last thoughts that you want to say before?
I don't think so, but this was really fun. I'm glad we got to do this.
Me too.
Thank you all for asking really interesting questions and coming up with really cool ideas.
And thank you for being our math co-conspirators. We all have the plot now. I have to end on a horrible Okay. Thank you, everybody. Thank you so much, Susan. And we wish you all a really lovely mathy day. Y'all take good care. Thank you.